Hello everybody, in this video I'm going to speak about code optimization using artificial intelligence. This video is inspired by the following statement. You take your production code already fully debugged and so on, you feed it to AI and ask to optimize and you return something that is going twice as fast. So, we immediately have a benefit of a cost cutting because you can save half of the computers, the computing grid, the servers, whatever, half of the licenses you need to put there. So amazing, right? Now, I will let you choose where this statement is coming from because there are three possibilities. First, I was dreaming yesterday night and came out of my crazy mind. Second option is that I saw some video with, these internet bullshit gurus speaking on YouTube, blah, blah. Third option, one of these mega managers, they manage maybe 1,000 programmers, and of course they never wrote a single line of code. So of course they manage all the programmers, makes sense. Don't worry, I'm not gonna enter in any technical detail, so it's meant to be, for a general audience. No understanding of coding is required from you. And hello everybody again, here is Damiani, your average inferior, trying to give feedback to the superior managers, if they are willing to listen to me, of course. Let's get into it. So, many people think, oh, if you write a code, then the computer will do. But then you send the code to your computer, it will take time to run. And especially if you have a big company, you might have a lot of stuff to run, and then you start buying more computer, more servers, more software licenses, and it becomes expensive. Okay. Don't think about your computer at home. Think about a big firm where they need to run a lot of stuff, big servers. Okay. So then if you are a manager, you want to go for cost cutting and you're like, oh, what do we do? All these licenses of this computer. One day AI appears on the planet, you take the production code, you have no clue what is there, you feed into AI poof, give you something optimized, you put them in production, oh, it's going twice as fast, so I can do 50% cost cutting. I'm a genius, right? I deserve a big promotion, big bonus, big blah, blah, blah. Okay. Wait a moment. What does it mean optimizing a code? That's the first question. Let's say I give you an example. You have a big file, big text file, and you want to send it to a friend. Now, you can just take the file and send it, right? But it's big, and maybe it doesn't fit in your email, so you need something else, some different connection, and then you see, oh, the file is big and takes so much time to download, to upload for me and download for the other. So what you can do is, for example, compress, zip the file, will be, I don't know, much smaller. Now you send it, it's much easier. So you optimize the sending of the file because it's smaller, and now you use less connection, less, amount of data to send. But on the other end, you pay a price because you need to compress, and compressing takes time. And then when the file arrives, need to be unzipped and will take time to decompress it. So you're saving on, let's say, internet connection, amount of data you send, but you're spending a CPU to compress and decompress. So this is a very basic example, but should tell you one thing. Optimizing code, even if you look just at the computer side, is not easy to understand what do you want. Because many times you have to think, it's like you have an equilibrium of points, and you have to find somewhere in the middle that is a reasonable compromise. Because if you want some code to run very fast, many cases you might read more memory. You might need more memory. So you load all the data in the memory and then you compute very fast. But you need to load all the data. So you use a lot of memory. You stress the hard drive, hard disk to read everything. Right? You might say, no, I want to use little amount of memory. Okay, you need a bit of data, you analyze them, save, you use a little of memory, but now the read and write and stop every time, the CPU is gonna take much more time for the execution. So, do you want to optimize the execution time, or do you want to minimize the consumption of memory? And the same can be for other things. You can compute everything or just saving the memory, so you have a bigger file and you use more hard drive, but you don't save every time. You don't compute every time the same stuff, or you can, So, generally speaking, you have the computer usage, the CPU, you have the memory consumption, the hard disk consumption, and the network consumption. And you cannot find, generally speaking, something that is optimizing everything at the same time. You have to make some deal. So, when you say, oh, I take this software, AI magically optimize it. Let's say there is no hallucination and there is no bug introduced. That's already a big question. But let's say you're lucky, or you do strong testing after and you're sure. Which optimization the AI did for you? Okay, now maybe it's going much faster, but you're going to fill the hard drive very easily. Okay, so, when I heard this manager, I was like, oh. But beyond this, there is let's say this was a purely computer usage, let me say in a different, very simple way. It was a simple computer usage task, optimization, okay. But then there is another problem. Today you have a code that is doing whatever task. Tomorrow you might need to change the code. Or I write the code, then whatever, I get sick or I get another job, whatever, or you fire me for whatever, I'm not here. And you need to read my code, okay? When the code is highly optimized, most of the time it's difficult to read. Okay, let me give you an example that even if you are not expert about computers, you don't know any coding, you don't know any math, I will try to make it very simple. I don't pretend you to understand the details, just look overall. So this is a video I did where I was explaining how to optimize a function. Okay, you can find it. Actually, this is the function we want to optimize. This is just a random function as an example. Don't take it, okay, you have a fraction with an exponential, some sign, and in the denominator you have a polynomial plus a log. Let's say you need to compute this. I write the code in this way, okay. Now, I wrote the implementation of this function in two places. The first is here in line 89, where even if it is written in a bit computer style, now it's a bit difficult to read, but you can go to the video if you really need, you have basically exponential of square root plus x minus sign divided by polynomial, and so on. Okay, so here, even if it is written in a computer style, it is exactly the formula you have seen before. So, you have the fraction with exponential, blah, blah, and polynomial in the denominator. You go to line 89, it's written in a bit cryptic way. If you don't know how to code, it doesn't matter, but more or less you can read it. If you go to line 101, this is the same function implemented in a super optimized way. It's going 5 times faster, something like that. I don't remember now. Okay, but you don't read it. What is all these numbers? How do you connect all these numbers with the formula I showed you before? Let's say that tomorrow your business change and you need to change this 7 into 8. Okay, just an example. You go here and you will find that here, okay, it's going now, is hidden in this, but here there's written 7, you change it to 8. Okay, let's say you need to change this x to the 4 to x to the 5. Okay, you go here in the code, you have x to the 4 and you just change 4 to 5, done. Okay, so it's easy to understand and it's easy to modify. And honestly, it takes very little amount of time to write it. Now, you might not know, if you're not an expert, you didn't watch my super beautiful video, that here in line 101, all this madness, with all these numbers in yellow, all these powers, this is exactly the same function. Now, I don't remember, I think it was going 5 times faster, something like this, 4 or 5 times faster. Okay, this is a highly optimized function, okay, that will compute exactly the same stuff as in line 89, but 5 times faster. So, let's say you ask AI to optimize this function. AI is so smart, look at my video, and copy my formula and put it there. But I'm not there to explain you. Okay, were you able to understand that this formula is equivalent to the formula in line 89? Even worse, let's say you need to change this 4 to 5. Where do you change it here? Okay, so this is another point that for me is really, really, really crucial. When you optimize code, you make it more rigid, more unreadable, more cryptic. So if tomorrow you needed to modify it, what do? And there is another point, actually. Let me go back to the screenshot. That the function in line 89 is going to be valid for any value of x. Okay, square root of x, you need positive values, but almost everywhere. Okay, any positive value. I don't know if there is some crazy point, but if you go for this polynomial with all these yellow numbers, this is valid only around 5.1. So another issue when you optimize the code, it becomes less stable somehow. Most of the time is fine-tuned, okay, to work in a specific situation, work very well there. But then when you get out of that situation, a code that is less optimized will be more stable in other situations, let's say. This is, now I gave an example of the function, but let's say I have a code that reads dates. Okay, I can implement a routine that checks that you, user, don't mess up making the days and the months because you are European, or month and day because you are, let's say, English, American. Okay, so I can implement some routine that checks or warn you. Are you sure that 0101 is, or 0102 is 1st February or the 2nd January? Okay. If you optimize, you can remove this function and will go faster, but then you introduce bugs. Okay. So, to make a long story short, when you optimize a code, you know, the more you optimize, the more becomes unreadable, the more becomes fragile, the more becomes difficult to maintain, the more becomes difficult to understand tomorrow. Okay? And of course, you have the problem I mentioned before that if you make it very fast, so little use of computer power, let's say, might use more memory. If you use less memory, you might use more hard drive, more network, and so on and so forth. That's one problem. The other problem is that it's less flexible, less reliable, less open to be upgraded tomorrow, less readable if I'm leaving ciao. Okay. So, in conclusion, feel free to believe that AI can solve all your problems. If you want to take your code, ask AI to optimize, get 50% faster and go around claiming victory so you deserve a big bonus, big promotion, feel free to do so. Okay? Be aware that it's a bit insulting because I spent the time maybe writing the code that you believe you can optimize. And if I didn't do so, it's because maybe I was thinking about tomorrow or whatever. It's quite insulting. But anyway, go around claiming your bonus, whatever. Today you have a 50% cost cutting. Tomorrow you will get 1 million times more expensive everything to fix. If you're happy, if everybody around you is happy, I will be just the nasty guy getting insulted. Sorry, I know I'm bad. Anyway, enjoy. Bye-bye.